Okay guys, here is the game plan for today. As you all know, our tectonics unit test is happening on Monday. So you've been finishing up learning targets, finishing up mystery tour. This is kind of our last full review of what's going on to give you some insight on the test for Monday. So in your assignments folder under tectonics, you should be able to see this purple tectonic review stations. Go ahead and open that up and you should see an assignment in there, tectonic review stations. Go ahead, grab this guy, put it into Notability. So you should be doing this with me right now. Tectonic review stations, still in my tectonics folder. Perfect. Now I want to stay on Schoology actually. And I want to go halvesies now with my review stations. So this is the document we just downloaded. And in Schoology, in that purple folder, I have 8 different stations of pictures or terms or information that's going to help me complete these activities. What I wanted to do with you guys today is 2 of the stations. Then you've got the rest of the time to crush through and make it happen. So here we go. Station 1, this is where we're going to start. We've got 3 images, starting with the basics. Type of boundary, crust happening there, and then a feature connected to this image. So shrink this down. Image 1, lots of clues going on here. We have a location, we have a visual, we even have arrows. Hopefully you're recognizing what this one is. Go ahead and fill it in here on boundary type. Remember, the plate boundary is the spot where the 2 plates come together. So it's right essentially in between these 2 arrows. So what crust do I have on the left compared to the crust on the right? And then go ahead and pause while you come up with a feature seen in this image for number 1. Picture 2. Boundary number 2, looking at the arrows, again figuring out what type of boundary we're working with here. So again, boundary type, this is going to be transform, divergent, convergent. Getting a little clue on the crusts for this one. So again, remember our crust, we want to list out 2, so it should be looking something like this. Ocean, continent, 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 ocean, ocean, something like that. And then a feature, that would be at that boundary. And image number 3, again, arrows should give you a pretty big clue what boundary we have, what crusts on either side of the boundary, which is again between the arrows, and then a feature happening at that spot. So go ahead and pause while you can see all 3 images and finalize your table. If you're in the classroom, go ahead and share out with your group what you got for this chart. Your boundary and crust should be identical, but features maybe would be a little different depending on what you looked at. So here's what we have so far. Number 1, looking at the arrows should be a good idea. This is convergent. And on either side of the plate boundary, our crust for this example is continent, continent. So we have those 2 pieces of crust, continental crust, pushing together. One of the biggest features here should be mountains. Bonus points if you recognize that these are non-volcanic. I was hoping that was the one that you recognized. Maybe you wrote down faults or folds. That was something we also listed in our learning target. Maybe something like shallow earthquakes could also be something. But mountains, non-volcanic should be your number one. And again, that's because there's no magma and no subduction zone making those mountains. Picture number 2. This should be a transform boundary. Again, we have this clue about the crust, but the boundary is between the arrows, continental on both sides, CC. Features here, one could be the fault. That's just the boundary or the crack created from the plate movement. The other big feature we really talked about here is shallow earthquakes. And finally, picture number 3, looking at the arrows moving away from each other, should recognize this is a divergent boundary. Again, crust on either side of the boundary line. This is all underwater, so we know that this is an ocean-ocean boundary. And again, feature list might be a little bit different here. Lots of choices. We could say MOR, mid-ocean ridge. Hopefully that was something you recognized. Another feature could be Rift Valley, the spot where the magma actually rises up. I know some people maybe have like new crust or youngest crust as that magma comes up and cools. That could be something that you're thinking about too. If we think earthquakes, it would be just shallow. Okay, so that's kind of what you got going on. A picture, some helping images to help you complete these. Got one about boundaries, one about seafloor spreading. This one is labeling some things on your picture, so you do need this in Notability rather than Google Docs. I want to take a look at number 8 together. Go ahead and open that one up. You can be looking at it on the screen. We have a couple things to label and then explain out. So now would be a good time to draw the following on your diagram. I would draw in and or label the warmest material and the coolest material, along with the most dense and the least dense. So now would be a great time to pause and get your diagram set up correctly. So when we think about labeling these things, we have to think about what this is. This is convection. And I've got the picture in there for you, reminding you that here at the mid-ocean ridge, this is the divergent boundary. Because look at our crusts here, they're separating. And over here where we have the trench, this is where it's coming together and sinking. This is our convergent boundary, right? The only reason those boundaries and plate movements exist is because of these convection currents or the flow of the mantle material. And that's driven by the heat of the Earth's core, right? We know the temperature is hotter as we go down inside the Earth. So as that core's heat radiates to the mantle, it comes in contact with this material and starts heating it up, causing it to rise. So for our warm mantle material, we should have it in this area. This warm material rising up, being heated from the core, something like that. Now we know as that material rises up, it starts to spread underneath the crust like we can see in the arrows, and it's farther away from the mantle, it cools and sinks back down. So we want to indicate that with our next set of arrows. This is where the material is furthest from the core. It's cooling and sinking back down. So we have the warm, we have the cool, we've got the colors associated with it. We want to think about density. We've been talking about density with our oceanic plate, right? We know more dense crust sinks down, and that's the same for anything that's more dense. It's going to sink downward. So when we look at our arrows, we should be able to associate more dense and less dense with what we've got so far, thinking about temperatures. So our warm rising material is the least dense because it's in fact rising upwards, while the cool material is the most dense. That's why it's sinking. So you should be adding this to your diagram right now, completing this part with me. So again, this whole cell is called a convection current, and it's heated, or it's created from the heat from the core, and it's driving the motion of the plates on the surface. Now, each part of convection, the warm rising and the cool sinking, is given a name. That's where our ridge, push, slab, pull comes in. This warm rising, less dense material, this is known as the ridge, push section of convection, right here, creating this separating divergent boundary. The more dense colliding and sinking down part of convection, this right here, this is our slab pull force. Again, associated with this subduction zone being pulled into the earth. Those would be great to add to your diagram, since those are what we're answering in question 2 and 3. What part of convection current is ridge push, and what happens there? So we want to simply explain that section of convection connected to ridge push and how the interior movement creates the exterior movement, making the divergent boundary. Same thing for number 3. We're describing the convection current coming together and sinking for slab pull, making these features and this boundary of convergent on the surface. So all of these things should be labeled in your picture so you can utilize those arrows to describe the motion inside to connect with the motion outside. So we did number 1, we did number 8. There's a lots of other pictures and statements in here to help you fly through this review, getting ready, like we said, for our test on Monday. You know, and some of this looks familiar. Some of it is just a quick circle. So these are circling things like you did in your mystery tour. Again, here's another label and all those things. So final thing is just make sure when you're done today, I need this today, Friday, you want to get this submitted. And on Sunday afternoon, I'm going to post a key for you to verify your information. I should still see your submission today, but I'll allow you to check it against the key so you can have all your information ready to go for the test on Monday. Looking at your gradebook, if you're missing any learning targets or mystery tours, that should be on your to-do list to wrap up for the weekend as we approach the end of the unit and the end of the try. With the test on Monday, here we go. Make me proud, team.